Okay, in today's video, we're going to be discussing the homologous series. What is the homologous series? Many of you might have heard about the homologous series if you are a high school student or if you are a university student just learning organic chemistry. You might have heard about the homologous series. The homologous series is a group of organic compounds that have the same general formula. They have the same general formula, have similar chemical properties, similar chemical properties, and show a gradual change in their physical properties. Each of the members differ from each other by CH2. That is to say, the difference between the first member of each family to the next is a difference of CH2. So we're going to discuss the different members of the homologous series, different members or families we can see in the homologous series. We have the major families of the homologous series. One, have what? Alkanes. Have alkenes. We have alkynes. We have alkanols. We have alkanoic acids. We have esters. We have amines. We have imides. We have the alkanals. We have the alkanones. If there are others, we're going to discuss it as we continue this video. If you have any family that you want me to discuss, kindly put it in the comment section. The ones that might be on a textbook that was not mentioned here. Okay, let's head into these different families as quick as possible. Now let's discuss the first the families in the chronological order. The first family is the alkanes. The alkanes have a general formula CnH2n plus 2. This is their general formula, where n is greater than or equal to 1. The alkenes have a general formula CnH2n, where n is greater than or equal to 2. The alkynes, sorry for that, I made a mistake with my spelling. The alkynes have a general formula CnH2n minus 2, where n is greater than or equal to 2. The alkanols have a general formula CnH2n plus 1 OH. This class will not last long. We're not going to dive deep. In our next video, we'll dive deeper into some important things you need to know. Now, these first three are known as hydrocarbons. Known as what? Hydrocarbons. Why are they hydrocarbons? Just like the name implies, they are composed of only hydrogen and what? Carbons. Hydrogen and carbons. Now, the functional group for alkanes, the functional group for alkanes is, for alkane, we have single bond. The functional group for alkenes is what? Guess what? Double bond. Then the functional group for alkynes is what? Triple bond. Is that not nice? Very nice. In our next video, I'm going to talk about the structure, how to draw structures perfectly in organic compounds, with exposing the core knowledge many college students and high school students omit, that makes them make a lot of mistake while drawing organic structures. Okay, so this is basically for the hydrocarbons. Then we have alkanols. Alkanols, their functional group is basically that OH attached here. OH is a sign that you are dealing with an organic compound known as alcohol. So this is their functional group. Okay, next we are going to go towards the alkanoic acids. Alkanoic acids. Alkanoic acids have a general formula CnH2n plus 1 COOH. Then we have the esters. The esters, they have a general formula let's use R COO R prime, where R prime means the alkyl group to the alcohol. This R is the alkyl group attached to the carboxylic acid. Now these esters, they are formed when a reaction known as what? Esterification takes place. What is esterification? It is a reaction between an alcohol and an alkanoic acid to form an ester, which is simply what I showed here. So our alkyl group that's attached to the carboxylic acid is which one here? Is this and this. The breakage is going to happen here, so I'm going to be having C2H5COO. Then there's going to be a breakage here, so this guy will be moving here, so I'm going to be having CH3. Are you with me now? So this is what? An ester, and this ester is called what? Methyl propanoate. Do you get that now? Okay, I'm not going to go too deep into this. When I enter into naming of impact nomenclatures, I'll move deeper into this. Okay, so that is it for you. That is it for. Then for amines, the general formula is CnH2n plus 1 NH2. For amides, the general formula is C double bond O NH2. 2. That is it for amines. Now, when we're talking about alkanones, or they are called ketones, their general formula is something like this: RC-O-R, something like this. Then we're talking about alkanals. Alkanals have another name known as what? Aldehydes. So now we're having RC-OH. This is it. This is general formula / functional loop for alkanals. So knowing why we are doing this thing basically is that having a knowledge of what you are dealing with looks like will enable you do this more quickly and efficiently. Are you understanding? Alright. The next one we're going to be looking at is our